It strikes me that while we talk about a global digital landscape, the underlying infrastructure, especially in AI, it often just defaults to English, doesn't it?
It really does. Most of the big, powerful language models are heavily English trained.
Which naturally presents a challenge for languages with, well, very different structures and nuances, like Arabic. And you're tuning in because you want to quickly grasp these important developments, right? Get those satisfying aha moments.
Absolutely. And today we're going to really dissect a piece of research that tackles this challenge head on in a very innovative way, actually.
Okay, so we're diving into the research paper Kuwain 1.5B, an Arabic SLM via language injection. We've also got some background notes on a research timeline, key people involved.
Right.
And our mission really is to understand the core academic advance here. How did these researchers manage to, well, ingeniously expand an existing language model to handle Arabic effectively? We want to focus on the novelty, the efficiency of their method.
Exactly. And what's so interesting, I think, is the potential to get around the huge cost and effort of building massive multilingual models from the ground up, especially for languages that maybe don't have as much training data readily available.
And the name Kuwain, I read, it's like a diminutive Arabic for universe, meaning little cosmos or something.
Yeah, tiny universe. It's sort of hinting at this compact yet quite comprehensive model. Sets the stage nicely, I think.
Okay, so let's start there. Let's unpack the fundamental problem this research is trying to solve. What was the specific gap they saw?
Well, the paper's intro lays it out pretty clearly. It's this prevalent English-centric bias in the big language models.
Right, we see that a lot.
Despite all the progress, they're just overwhelmingly trained on English stuff. And this creates inherent limits when you try to apply them to a language like Arabic.
Because Arabic is just different, morphologically, syntactically.
Completely different morphology, syntax, semantics. It all differs significantly from English. And that mismatch, it leads to, poorer performance. It just fails to capture the richness of Arabic.
So even the open source models fall short.
That's what the researchers point out. Yeah, they often don't really provide adequate support for the complexities you find in Arabic language tasks.
Okay, so the state of the art has this kind of linguistic blind spot. So what's the big idea then, the core innovation they're proposing?
The central idea is this concept they call language injection.
Language injection. Okay.
So instead of the really computationally heavy process of, fully retraining a huge model on Arabic data from scratch.
Which costs a fortune and takes ages.
Exactly. They developed this method to efficiently sort of inject Arabic capabilities into an existing, mostly English-trained small language model. In this case, it was Tiny Llama 1.1B.
Tiny llama, right?
And through this targeted adaptation, they created Kuwain, which is a 1.5 billion parameter model. The real novelty is getting significant Arabic understanding without that full retraining cycle. It's just much more cost effective, much more resource efficient.
Language injection, it sounds like a very precise, almost surgical intervention. So what are the key technical pieces? How do they actually do the injection?
It really boils down to two main technical contributions.
Okay.
First, they extended the model's architecture itself. And second, they did a very targeted expansion of the tokenizer's vocabulary.
Right, let's take it architecture first. They added layers.
They did. They strategically added 8 new trainable layers, but crucially, they added them on top of the original layers of Tiny Llama, which were kept mostly frozen.
Mostly frozen. Okay, so it's not like they rebuild the whole thing, just careful additions. How did they figure out where to put these new layers? Was it random?
Oh, definitely not random. Their experiments on placement are actually quite interesting. They took some inspiration from another project, Llama Pro, but adapted the idea specifically for language adaptation, not just, say, adding domain knowledge.
Makes sense.
And they found some key things, like just stacking the new layers one after another. That was suboptimal. It could even make the training unstable.
Ah, okay.
And they also found it was really necessary to keep the very last layer trainable. That seemed key for stability. Just spreading them evenly didn't work best either.
So quite specific findings. Is that documented?
Yeah, Figure 4 in the paper shows the training loss for different ways they tried inserting the layers. You can see the differences empirically.
Interesting. So a very deliberate architectural change, validated by experiment. Okay, what about the second piece, the vocabulary expansion? Why was that so critical?
Well, vocabulary expansion is absolutely vital because most tokenizers built for English just don't have many ways to represent Arabic script or its very rich morphology.
The tokenizer is how the model first sees the text, right? Breaks it down.
Exactly. It breaks text into fundamental units, tokens, and if your vocabulary doesn't have enough Arabic tokens, the model struggles. It might break Arabic words into weird, meaningless little pieces.
Which isn't efficient or helpful for understanding?
Not at all. So the researchers tackled this by adding about 26,000 new Arabic tokens. They used sentence piece for this. The final vocabulary ended up around 54,000 tokens total.
And how did that compare to other Arabic models?
The paper has a table, table 1, comparing it. They look at Kuwain versus like Arabert and Jais. It shows Kuwain strikes a pretty good balance, in terms of how much they expanded the vocabulary versus the final size.
Okay, so a bigger, better Arabic vocabulary means more nuanced, more efficient processing right from the start. One of the big worries with adapting models is, well, you teach it something new, does it forget the old stuff? How did Kuwain avoid catastrophic forgetting of its English?
Ah, yes, catastrophic forgetting. That's where freezing those original tiny llama layers really comes into play.
Right, you mentioned they were mostly frozen.
By keeping the vast majority of those pre-trained layers locked and only training the new layers primarily on Arabic data, they managed to hold on to the existing English knowledge quite effectively.
Just by freezing, was there anything else?
Well, here's a really interesting finding. They discovered that mixing in just a small amount, about 20% of Tiny Llama's original English training data during the Arabic training phase, acted like an anchor.
An anchor.
Yeah, it sort of reinforced the model's English abilities, prevented them from degrading too much. Table 2 in the paper actually shows what happens if you use less English data. They had a variant, Kuwain 1.5B, where performance dropped, so that 20% seemed like a sweet spot.
Wow, that's elegant. Selectively train the new bits, but anchor the old knowledge with just a fraction of the original data really speaks to the efficiency.
It really does.
Okay, so how does this whole language injection thing, the layers, plus the vocabulary, plus the freezing stack, up against just, taking Tiny Llama, expanding the vocabulary, and training it on all the Arabic data without adding new layers? The more conventional approach, maybe?
They thought of that. They set up a baseline called Kuwain Naive to test exactly that.
Kuwait naive. Okay,
So this version got the full Arabic dataset, it got the expanded vocabulary, but crucially, no layer extension, no architectural change.
and the result?
The results, they're in Table 3, they really highlight the catastrophic forgetting problem. Kuwait Naive saw a significant drop in its English performance. It learned Arabic, sure, but at the expense of English.
Ouch, so it forgot a lot.
It did, but Kuwain proper, the one with language injection, with the layer extension Table 4, shows it maintained strong English performance while achieving comparable results to Kuwain Naive on the Arabic benchmarks.
So the lay extension wasn't just about learning Arabic better, it was key to keeping the English too.
Exactly. It shows the synergy, The two parts, layer extension and vocabulary expansion, plus the careful training worked together.
Okay, that makes the advantage much clearer. So the bottom line then, how did Kuwain actually perform out in the wild against other Arabic models on standard tests?
Well, considering its size, just 1.5 billion parameters, which is relatively small these days.
Yeah, tiny compared to some?
It achieved really competitive performance on standard Arabic language benchmarks. Table 5 shows it's a massive improvement over the base Tiny Llama model on Arabic tasks, as you'd hope.
Right.
But maybe more impressively, when they put it on the Open Arabic LLM leaderboard Table 6, has the details Kuwain held its own against much, much larger models.
How much larger?
Some Arabic-centric or multilingual models that are like up to 10 times bigger in parameter count.
10 times. Wow.
Yeah. So it really underscores the efficiency of this language injection method. It shows its potential, especially if you're in a situation without massive computing resources.
And these other models, they were trained differently.
Oh, yeah. The compares it to models like JACE, HGPT, Arabian GPT. Kuwain's performance relative to its size is pretty remarkable.
That really is a strong argument for the efficiency. Okay, so let's sort of wrap up the core contributions here. What are the main academic takeaways from this research, and where do they see it going next?
I'd say the primary contribution is really introducing and validating this language injection method. They've shown it's a novel and efficient way to add a new language to a model.
Right, demonstrated specifically for Arabic on an English base.
Exactly. They rigorously showed it works. You get good Arabic understanding, minimal compute compared to retraining, and critically, you don't lose the original English knowledge significantly.
And future plans.
They mention wanting to scale it up. Try applying the method to larger base models, not just tiny llama, and also train on even bigger Arabic datasets.
To see if the benefits hold at scale.
Precisely. And also to investigate more deeply the relationship between how good the base model is to start with and how well the language injection works for adding the new language. Does a better base model learn the new language even better with this method? That kind of question.
Okay. So the core aha moment for you, the listener, is really getting your head around this innovative, efficient method for building multilingual AI. It kind of bypasses that super expensive, time-consuming full retraining loop.
Right. It offers a really promising path forward, especially, I think, for languages that might otherwise get left behind in the LLM race because they don't have the same resources as English.
It's about smart, targeted adaptation leading to pretty significant gains. Much more efficient.
Exactly. And, it does make you think. It raises some fascinating questions for the future, doesn't it?
Like what?
Well, if we can inject a whole language this effectively, what other complex capabilities could we maybe integrate into existing models using similar targeted methods?
You mean like injecting specialized knowledge? Or maybe reasoning skills?
Could be. Could we see injection techniques for adding specific domain expertise or particular types of reasoning? It feels like a really provocative area for future work beyond just language.
Definitely food for thought. A new way to think about model enhancement, maybe.
Potentially.
Well, if you're interested in the cutting edge of multilingual AI, we definitely recommend, taking a look at the original research paper and check out the Open Arabic LLM leaderboard too. It gives a great overview of the field.